Namaste, welcome to Pythagoras Academy. This is Vikram Dachepally. How important is it to understand a question? Understanding a question 100% is almost arriving at the solution. I'll give you one such example in this video now. Look at this problem statement. A, B and C are three persons standing on the vertices of an equilateral triangle of side A, and it is given that A moves towards B, B moves towards C, and C moves towards A with constant speed u. The question is, find when and where A, B and C will meet, at which position, and after how much time they are going to meet if they follow this condition. Reading this question, one may immediately jump into conclusion that there is no possibility of A, B and C meeting, because A is moving towards B, B towards C, C towards A. They are stuck in this infinite loop. But that is not true. Let us analyze this question properly. Let us try to understand the question in detail. For example, the person has moved towards B for a so consider the motion for a very short interval of time. Take a very small time dt or delta t. In that time, A is finding B somewhere here, so he moved, and B finds C on the other vertex, so B starts heading towards C, and C will head towards A. Fair enough. So there is no problem till here. Next instant, A is finding B not along the side of the triangle but somewhere here, so A will head his path towards the B, and B is heading his path towards C, C towards A. Now A finds B somewhere here, B is finding C somewhere here, C towards A towards B, B towards C, C towards A. So ultimately they are meeting. Point number one, they are going to meet. Definitely there is a possibility and they will meet. It is not given in the question that A, B and C are moving along the edges of this triangle. Constant speed u, they are only maintaining constant magnitude, but it is not constant velocity. The path that A, B and C will trace following these conditions would be spiral path. It is not straight line path. So they will meet, and by symmetry we can say that they are meeting exactly at the center of this triangle, which is known as centroid of the equilateral triangle. Now 90% of the solution is done by understanding this question. Remaining 10% is applying simple math to find out how much time they'll take to meet. You can understand this like this. Say there's a triangle, consider a triangle. A, B and C are always on the vertices of some or the other equilateral triangle. This is the initial position. This is C. Now when A is moving towards B, B towards C, and C towards A, if you join their positions, you're getting another triangle. Yeah. One. Let's make this. Yeah. Now they are the vertices of this equilateral triangle. After some time, so A is moving towards B, B towards C, C towards A. If you join their positions, you're getting a new triangle. Again, A towards B, B towards C, C towards A, triangle. Another triangle. A towards B, B towards C, yeah. A towards B, B towards C, C towards A, this is another triangle. A, B, C. So finally they meet here at the center. The path traced by A or B or C will be this. So the path traced by B is this one. Similarly, the path traced by A is this. Path traced by C. Three of them are tracing spiral path. Now, how do we find the time taken for them to meet at the center of the triangle? That is not that complicated. Method 1, the first method. The reason why I drew this figure is that at any given point of time, if you take the snapshot of these three persons, they are on the vertices of some equilateral triangle. The total displacement of any person, let us take person A, is from his initial position, that is the vertex, to the centroid of the triangle. I'll use say G, centroid G. The length from the vertex to the centroid, this is the displacement of the person. How do I find the displacement? By simple math. Say this is 60 and this is A. So if you drop the perpendicular from vertex to the opposite side, it will be altitude, it is also median, it is also angular bisector, because it is an equilateral triangle. Now the length AD is nothing but root over A square minus this length would be A by 2, A square by 4, which is root over 3 A square by 4, that is root 3 A by 2. The length AD is root 3 A by 2, AG is nothing but the distance from the vertex to the centroid, and we know that centroid divides the median in the ratio of 2:1. So the length AG, so this is two parts and this is one part, so 2/3 of root 3 A by 2, which is A by root 3. The length AG is A by root 3. Now, the velocity of the person A is always, at any given instant of time, it is always along the side of the triangle, any triangle. So if you observe, initially his velocity is directed along the side of this triangle, at this position, side of another triangle. So velocity of the person A is always along the side of a triangle, and this angle would be 30, and his magnitude of velocity is u, so which is u, and the constant velocity that is maintaining along the displacement is u cos 30, which is u root 3 by 2. A or B or C is maintaining a constant velocity of u root 3 by 2 towards the displacement always. It is as good as the person A is moving with a speed of u root 3 by 2 and straight away going to G. The effect is same. Now I will consider the displacement, effective displacement of the person, that is A by root 3, displacement is equal to constant velocity in the direction, that is u root 3 by 2 into time t. Displacement is equal to velocity into time. So the time taken to reach that point is 2a by root 3 into root 3, that is 3, 2a by 3u. This is method 1. What is method 2? We can also solve this by method 2. Method 2 is the concept of relative velocity again. A and B. A's velocity at any point of time is u along the side. B's velocity is at any point of time is u along the side of the triangle. Now this is angle 60. If you resolve the component of, if you resolve the velocity u of B along this side AB, that would be u cos 60, which is u by 2. At any point of time, the relative velocity of A with respect to B, velocity of A with respect to B is u minus u by 2, because they are in the opposite directions. That is 3u by 2. As seen by B, as observed by B, A is always maintaining a constant velocity of 3u by 2. And when they finally meet, the initial displacement or the initial separation is A, and finally when they meet, the separation is 0. The relative displacement that A has covered to meet B is A. So relative displacement A is equal to relative velocity, that is 3u by 2 into time t. So even from this, by single step, I can get t is equal to 2a by 3u. This is the time. Suppose the question is to find the length of the spiral path. They're tracing the spiral path and I have to find the length of the spiral path. I got t is equal to 2a by 3u. This is what I got, 2a by 3u. The length of the spiral path is nothing but the distance traveled by A, B or C. Reading the statement, find the length of the spiral path, you might think it's very complex, but it is very, very simple. Length of the spiral path is nothing but distance traveled by A, B or C. And they're always having constant speed, which is u. So distance traveled S is equal to u into t. So distance is equal to u into 2a by 3u. So which is 2a by 3. So the distance traveled by A, B or C, which is nothing but the length of the spiral path that they have traced, which is 2a by 3. Very simple, one step we got this answer. And you can also apply this for a hexagon. Similar approach. Suppose you have a hexagon, 6 sides, there are 6 persons, A, B, C, D, E and F. A is always moving towards B, B towards C, C towards D, D towards E, E towards F, and F towards A with constant speed u. Then when will they meet, and where will they meet? At the center of the hexagon. How do you find when they'll meet? It's very simple. Now take any person. Suppose take A, his speed is u. Now this angle would be 60 because the entire angle, each internal angle of the hexagon is 120 degrees. So this is 60. So from the center of the hexagon, let me say this is G. The length AG would also be A, side of the triangle, because it forms an equilateral triangle. So this is also A. The person A's velocity is u along the side. The component of his velocity towards the displacement is u cos 60, which is u by 2. The effective displacement of the person is AG. So initially is at this point and finally is at G, and the effective velocity that he is maintaining always towards the displacement is u by 2. So A is equal to u by 2 into T. So T is equal to 2A by u. This is the time. If you know the time, you can find the length of the spiral path, and you can also do this by another method. You can try by yourself by doing this in the second method, the relative velocity concept. So this is all about this problem, the very beautiful problem and a smart solution. If you have any questions or queries or suggestions, you can always use the comment section to interact with me. I'll be more than happy to respond and receive your feedback. This is Vikram Dachepally signing off. Namaste.